Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. So total strength currently is 8 participants. So we will wait for 2-3 minutes and then we will start with the lecture. Okay, just tell me whether the screen is visible, whether the PPTs are visible. Yes. PPTs are visible to you.
No, ma'am.
Just check it.
Yes, ma'am. Present.
Okay. We will wait because 9 participants are there. We will wait for 2 minutes and then we will start. Okay, so let us start with the lecture. Okay, so in previous lecture, we have started with the display devices. In that, we have seen the CRT, that is cathode ray tube, its construction, that is the diagram of CRT we have studied. In that, we have seen there is a electron gun, or then we have seen the focusing system and vertical and horizontal deflection plates. Okay, so use of every element in that CRT we have studied, and we know that our CRT's monitor or the output screen is covered with a phosphor coating. So you can view here the phosphor coating is here, and these are nothing but the units of CRT. And when the electron beam falls on this phosphor coated screen, then green color light gets emitted, and that is showing the actual position of the pixels on the output screen. So this is how you are going to generate the output on the device. So let us start with the second device, which is called as color CRT. Okay, so color CRT. So a CRT monitor displays color pictures by using a combination of phosphors that emit different colored lights. So in earlier CRT, what we have seen, we are having only green phosphorus coating layer, and that's why you are able to generate the green light on the output screen. So earlier black and white type of monitors for computer as well as TVs, they are using this old CRT method with single color display. But here, by making use of different phosphors, so here we are going to have the combination of different phosphors, and they emit the different color light. So we have seen earlier in CRT, we have used the green phosphor coating, and that's why the green color light gets generated for the output. And here, as we are using the different colors in phosphor coating, so we are able to generate the different colors on the output screen. So it generates a range of colors by combining these lights from different phosphors. So we can have the combination of colors, and we will get number of shades or number of colors generated by making use of different phosphors in color CRT. Here in color CRT, for displaying the color pictures, there are two type of techniques. One is beam penetration. Sorry, here it should be beam penetration method. I will make the corrections afterwards. Here it is beam, BEAM. So beam penetration method, as the beam penetrates the or it is using the penetration method with a beam in this technique. And the second is called as shadow mask technique. So these are the two techniques used in case of color CRT. So here beam penetration method, in that beam penetration method, in this it is used with random scan monitors. So we have seen there are two types of scanning possible. One is raster scan and other is random scan. So in raster scan, we have seen that line by line we are going to display the output. So every time one line is getting scanned, the control will return back to the left hand side, and this process of moving the pointer zigzag is followed, right? So this is called as your raster scan, and in random scan, the total screen gets blank. So for a certain time, the whole screen will become blank, and in the next iteration or in the next time bound, you are able to view the output on the output screen. So here in a raster scan, line by line display is taking place, and here the whole screen becomes blank, and on the whole screen the output will be displayed. So that is called as your random scan monitors. In this technique, the inside of CRT screen is coated with 2 layers of phosphor. So in earlier method, what we have seen, this is your CRT, and the portion which is showing you the output. So this is nothing but your output screen. This curvature represents the output screen. So earlier it was having only one color, green color phosphor coating we have seen. But now in this color CRT, we are having 2 layers of phosphorus. So it is having the 2 layers of phosphorus, usually red and green. So red and green, 2 layers are there in this phosphor coating. So on the output screen, there are 2 layers of phosphorus present. One is red, outer layer is red, and inner layer is green. Okay, so this output outer layer is red and inner layer is of green color. Okay, the displayed color depends on how far the electron beam penetrates into the phosphor layer. So it is very important. Here the electron gun emits the electron, and that beam is striking on the phosphor coating. So it is totally dependent upon the speed of this electron beam, that how far it will penetrate these 2 layers. It depends on the speed of this electron beam, that how far it will penetrate. So if the speed is less, it will be reaching to the green layer only. If the speed is high, then it will be penetrating the green and reaching towards red. And as the speed is varying, the color which you are going to get on the display is also varying. So when it falls on this, you will get the green color generated, and when the penetration is done through it, then you are able to get the red light. So the displayed color depends on how far the electron beam penetrates into the phosphor layer. So how far it will go, depending upon that, the color will change. The outer layer is red. I have already discussed. The outer layer is red and the inner layer is of green phosphorus. Okay, so a beam with slow electron excites only the outer red layer. So whenever you are having the slow electrons, then only red layer, outer layer will get excited, and fast electron penetrates through red and excites the inner green layer. So here the penetration is done when electron beam is with a faster electrons, then it will penetrate the outer layer and gets the green color displayed. Intermediate beam of intermediate speed beam will give red and green both light emitted with 2 additional colors. So a combination, when moderate speed of the electrons are there, then along with green and red, you are able to view the orange and red color also. So here you are able to get 2 more colors on the output screen if moderate speed is there. The beam acceleration voltage controls the speed of the electrons and hence screen color at any point on the screen. So the voltage is responsible for changing the speed of this electron beam. and as the speed is changing through voltage, it also changes the display color. So color is in turn dependent upon the speed of the electron beam, and that speed is in turn dependent upon the acceleration voltage. So voltage is main control unit which will control the color on the output screen. So what are the merits and demerits of the color CRT? In that, beam penetration method we have studied, and beam is penetrating through the two layers of green and red phosphorus. So what are the merits and demerits? So first is, it is inexpensive technique, right? Because it needs only two phosphor coatings, green and red, and able to generate 4 colors out of it: red, green, orange, and yellow. So these are the 4 colors getting generated with less expenses. That is the merit, positive point of beam penetration method. And what are the demerits? It can display only 4 colors, right? Because on the output screen with this beam penetration method, we can display only 4 colors, that are red, yellow, green, and orange. So only 4 colors are getting displayed, and the quality is not good as compared to other techniques. So it has to be there because it is based on the earlier methods of cathode ray tube, and the beam penetration method is giving you the moderate quality of the output picture. So the quality of the picture is not good as compared to the other methods. So these are the 2 drawbacks of beam penetration method. Okay, all of you are getting it?
Yes, ma'am.
Okay, so let us see the second method. So in color CRT, one earlier method was beam penetration, and now we are going to see the shadow mask method. So the second method of color CRT is shadow mask. So in this shadow mask method, it produces a wider range of colors than beam penetration method. So the drawback of beam penetration method of displaying 4 colors only, that was overcome by using this shadow mask, and it is producing wide range of colors. Then second is, hence this technique is used in raster scan display, including color TVs. So color TV is making use of this shadow mask method, and they are useful in raster scan display. So raster is nothing but line by line zigzag type of display. In that, it is using the shadow mask method. In a shadow mask technique, CRT has 3 phosphor color dots at each pixel position. So we are going to have, for every pixel, the pixel is composed of 3 dots of 3 colors. So every pixel is having 3 dots, and each dot is representing red, green, and blue, RGB colors. And by making the combination of these 3, we are able to get the wide range of colors and in return. So in shadow mask, CRT has 3 phosphor color dots at each pixel position. One phosphor dot emits red, another emits green, and third emits blue light. So RGB. So red, green, and blue light, these 3 lights are emitted in the shadow mask technique. So see here the actual working of the shadow mask technique. So it is the output screen represented with white paper. This is your shadow mask. So shadow mask is nothing but a partition which is having several holes in it, and your 3 beams, that is 3 guns, red, green, and blue. These 3 guns are emitting the electron, and they are coinciding at one point where the whole of this shadow mask is present, and those rays are traversing through that hole and it will fall on this output screen. Now every pixel of the output screen is composed of 3 dots, red, green and blue, and depending upon its color, if I want to display the red color dot, then at that time green and blue value will be 0. So you are able to generate only red color for that particular pixel. So every pixel is represented in terms of a triad. So triad means having 3 colors. So it is every pixel is displayed in 3 colors, and the combination of these 3 colors will generate a wide range of colors on the output screen. So this is how the shadow mask technique works. So this particular window, or we can say this particular partition, is called as shadow mask, which has number of holes in it. At those holes, the three emissions of the electron gun, red, green and blue, they concentrate on one particular point, and through which they are getting displayed on the output screen. So this is how the color CRT works with with shadow mask method. Okay, so this shadow mask method has 3 electron guns. Just now we have seen in the diagram, one for each color dot on triad, and a shadow mask grid just behind the phosphor coated screen. So on this in between the gun and the phosphor coated screen, you are having the shadow mask. The shadow mask consists of series of holes aligned with the phosphor dot pattern. So here you are having the number of holes on the shadow mask. The 3 electron beams are deflected and focused as a group on the shadow mask. So just now we have seen the 3 guns are directed and they are focused on one hole of the shadow mask and then passed further to the screen. Then they pass through a hole in the shadow mask and they excite a dot triangle. So they are going to excite a dot triangle, and depending upon the color of that particular triangle, the appropriate color will be selected out of 3 guns. A dot triangle consists of 3 small phosphor dots, red, green and blue color. A dot triangle, when activated, appears as a small dot on the screen which has color of combinations of 3 small dots on the screen. So just now we have discussed that the when through shadow mask, when the beam will fall on the output screen, it forms a triangle. Though we are observing the triangle is over here, it is so small in size that it appears as a dot in the output screen. So a triangle, though it is in a triangular manner, these are so small that it appears as a small dot on the output screen with 3 colors combination. Then by varying the intensity of 3 electron beam, we can obtain the different colors in the shadow mask CRT. So we have already discussed that we are changing the intensity of the 3 electron beams. So if I want to display here red color, then we are making the intensity of the red electron gun as 1, and remaining 2 guns will have intensity as 0, so that I will be able to view a red dot on the output screen. Similarly, I can have the combination over all the 3 electron guns, and different intensities will make the different colors on the output screen. Okay, so that method of shadow mask is used in case of raster scan display. So the method that we have learned here, shadow mask method, it is mainly useful in a raster scan display. So let us learn what is raster scan display. So all of you are getting the shadow mask method.
Yes, ma'am.
Yeah. Okay, so let us see the raster scan display. So we have already discussed that the shadow mask method is used in raster scan display, where the electron beam is swept across the screen top to bottom one at a time. So we have discussed, see in this diagram, it is starting with the top left corner and it goes till the right hand side boundary is reached, and then it will pass its control to the next line, and this process of moving the beam from left to right is continued. And as soon as you get any point pixel with different intensity, that pixel will be plotted on the output screen line by line. So on one line, whatever the pixels are having different intensity, that are getting displayed over here, and the complete picture will be present on the output screen as soon as your control will reach to the lower right corner of the screen. So this process of zigzags is continued till you reach to the rightmost lower corner. Okay, so that is how the raster scan display works. So this is electron beam which is swept across the screen. So swept means moved in zigzag manner from top to bottom one at a time. So one line is scanned at a time. Beam moves each row. Intensity is turned on and off, and it will create the pixel. So when the intensity is off means the background pixel will be getting displayed, and when the intensity is on means this is picture pixels. So if I want to draw this triangle, then those pixels are having the intensity equal to 1 or on. So we are making that intensity on, and that particular point will be displayed on that line. Next is refresh or refresh the frame buffer. So information of picture stored on memory area. What is the meaning of that? Once the whole picture is getting displayed, then the refresh cycle is carried out. The refresh cycle means the whole screen will become blank for some time and again will start displaying the next picture. So that is called as your refresh cycle. So making the occupied. Okay. Due to some network issue, now it is clear. Yes, students, whether my voice is clear now?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Okay. Thank you. So this this particular image is getting displayed as soon as I reach on the right corner. And once the image is displayed completely, then the refresh cycle takes place. Refresh means the whole screen will become blank and it will start preparing the next display on the output window. So this image, ही image तुमची डिस्प्ले झाल्यानंतर रिफ्रेश सायकल होईल, ज्यामुळे this particular control or the electron beam will move again to the top left corner and start drawing the picture once again. So this method is called as refreshing the buffer. Then pixel value is retrieved. So once you plot this picture, then those pixel values are retrieved from the memory and plotted on the screen. So this information of this triangle, the pixels which are present on this triangle is present in the memory, and while displaying any picture, that information will be retrieved from the memory and then it will be plotted on the output screen. So this is how the raster scan display works. Now, what is horizontal retrace and vertical retrace? So horizontal retrace is nothing but when your beam is moving from left to right, as it reaches the rightmost pixel, it will move back horizontally to the next pixel on the next row. So this movement of beam from right corner to the left corner is called as your horizontal retrace. So it is the beam returning to the left screen after refreshing each scan line. So after completing this each scan line, the control will move to its next line and left corner, and that is called as horizontal retrace. And similarly, vertical retrace is nothing but after completing this whole picture, after displaying this whole picture, when your beam will reach to the rightmost bottom corner of the screen, then again it will return to the top left corner. बीम इथे राईटमोस्ट कॉर्नरला पोहोचल्यानंतर परत ती रिटर्न येते टॉप लेफ्टला. या प्रोसेसला म्हणतात तुमचा वर्टिकल रिट्रेस. सो आफ्टर एंड ऑफ द फ्रेम, फ्रेम मीन्स वन डिस्प्ले, एक डिस्प्ले झालाय, एंड ऑफ फ्रेम, बीम रिटर्न्स टॉप लेफ्ट स्क्रीन अँड इट विल बिगिन द नेक्स्ट फ्रेम. आणि नेक्स्ट पिक्चर ते प्लॉट करायला सुरुवात करेल, त्याला म्हणतात वर्टिकल रिट्रेस. आणि रास्टर स्कॅन मेथड वरती कोण our regular TV set is working with raster scan display principle. So here in TV also the electron beams moves from left to right, top to bottom, and again moves the control back to the top left. So horizontal and vertical retrace is followed in our TV sets. So this method is used in TVs. Now, what can be the advantages and disadvantages? So first is less memory requirement. Second is high degree realism, that is advanced shading and hidden surface removal technique is used here. It is used in computer monitors and TVs. So these are the positive points, that it requires less memory because the whole picture is getting stored in one frame, and refreshing it will be simply moving your pointer to the top left, simply moving the pointer, that is scan line, to the top left. That is only required, and the frame buffer only. Here high degree realism. So advanced shading and hidden surface removal techniques are useful, or they are applied in this. So it will provide you the high degree of realism. The picture will be more clear and more realistic in nature. So it is used in computer monitors and TVs. So these are the advantages of raster scan display. And what are the drawbacks? So drawbacks is the line is plotted, that if I want to plot any line, then as it is a pixel wise representation, point by point I am displaying the image, and that's why the line plotted will be zigzag in nature. So you can observe here, sorry, here. So if you observe this last line, the bottom line, base line, then as it is slanted one, you are able to view that the line is somewhat zigzag in nature because it is based on the pixels. So pixel wise representation is done. One by one pixel is getting plotted, and that's why the line is zigzag in nature. That is the first drawback of it. And you can observe that as the screen is divided into number of pixels, the resolution is also less. So it is having the less resolution. So these are the two drawbacks of raster scan display. First is line plotted is zigzag in nature, and second is it has low resolution. So to overcome these two things, drawbacks, we are switching to the new method, which is called as random scan display. So here is the random scan display. Here also the electron beam is used to draw the image, but here we are not scanning the whole screen line by line, but we are scanning each vector of your image. So if I want to display a triangle, then I'm not going to scan the lines on the output screen. Instead, I will be scanning the image. So image is scanned and one line will act as one vector, and that is getting displayed on the output screen. So electron beam is present, and it is responsible for drawing the output picture on the screen. Then it is directed towards the screen only. Here the vector display or stroke writing or calligraphic display is followed. So here vector display means what? The whole line is getting displayed at a time. Calligraphic display, the picture is drawn by one line at a time, like that. So the whole vector is getting drawn at a time. It is not the pixel wise entry on the output screen. Example is pen plotter. So earlier example of raster scan was the TV, but here the pen plotter works in this manner. It is working according to the image, the vector under display. The refresh rate depends on number of line to be displayed. So if I am having 3 lines to display, then maybe 3 seconds time will be required, and after that you will call the refresh cycle. But if number of lines are more, suppose I want to draw a 10 lines, and that will form a house like structure, right? मला एक house display करायचे output screen वर, which is composed of 10 lines. So obviously until you complete that drawing of the house, you cannot go for the refresh cycle, and that is the rate of the refresh cycle or refresh rate is totally dependent upon the lines to be, number of lines to be displayed. So at a time the vector or one line is getting displayed, and such if few lines are there, then refresh rate is less. If more number of lines are there, then obviously the refresh rate will be more. Next is refresh buffer. So here the picture definition or the image is getting stored in terms of set of lines. So here we are going to store the image in terms of set of lines, and the memory area is also associated with those number of lines. Then in the picture, it is going to draw a line, and it takes 30 to 60 times in a second. So in order to draw a line, such 30 to 60 lines are getting drawn in 1 second. That is the speed of drawing the line on the output screen. So that is about the random scan display. Now, as this display is vector wise, or a complete line is getting displayed at a time, and that's why the line is more clear. because a pixel wise plotting is not taking place. Instead, the vector wise plotting takes place, and that's why there is no zigzag kind of line present. So distortions in the line are getting overcome, and that is the drawback of raster scan display. In raster scan display, this line is having the zigzag form, but in random scan, the line is no more in zigzag form. It is the straight line. So that a drawback is removed. And as the line is not distorted, obviously the resolution or picture quality is good in case of random scan displays. Then what are the advantages and disadvantages? So first is it has very high resolution. Yes, because no line fluctuations are there or distortions are there. So you will get a good picture quality. Easy animation, obviously, because vector wise display is taking place, and that's why if I want to give motion to that particular picture, for example, on the output screen, initially the triangle is here and I want to shift it towards right till it reach to the right hand side. So this animation effect I have to provide to this triangle. So I'm moving this triangle a little bit to the left till to the right till it reaches the rightmost edge. So this animation is easy because at a time the whole line is getting plotted. So shifting of this line to a new location will consume less time and animation will be easy. Instead of this, if I'm using the raster scan display, then what will happen? The earlier triangle was here, and every time for plotting the pixel, I have to scan the whole screen, and the next time it will be plotted over here. So it will not having good resolution, as well as it will take large amount of time as the whole screen is getting processed in every frame. But here only the vector or the image which is to be drawn, that only is getting displayed. So that is easy animation is possible by using the random scan display, and it requires less memory because only the information about the image I need to store. But in raster scan display, every pixel position, right from background pixel and picture pixels, all those things I need to store into the memory. So it requires less memory. That is the advantage. So high resolution, easy animation, and requires less memory are the advantages. And what are the disadvantages? So it requires intelligent electron beam, that is the processor controlled. Why? Because the electron beam is passing, or electron beam is responsible to draw the image directly on the screen. So your electron beam should come at this particular position at the beginning. आधी आपण काय करत होतो, रास्टर मध्ये सगळंच आपण स्कॅन करत होतो. सो जिथे पिक्चरचं इंटेन्सिटीचं पिक्सेल असेल तेवढंच फक्त आपण एक त्या पिक्चर इंटेन्सिटी मध्ये काढत होतो. सपोज हा ट्रायंगल रेड कलरचा आहे, सो इथे ही तुमची स्कॅन लाईन इथे आल्यानंतर इथे तुमचा रेड कलरचा एक डॉट तयार होईल. नेक्स्ट स्कॅन लाईनला तो दुसरा तयार होईल, तिसरा तयार होईल. सो देयर वॉज नो नीड ऑफ इंटेलिजंट इलेक्ट्रॉन बीम. पण आता काय होतंय, now you have to come to directly the position where the picture is starting. So you need to occupy this particular position, and for that your electron beam should be intelligent. That is, you should have the electron beam which is processor controlled, so that it will find its path for drawing the image. Okay. Then second is it cannot draw a complex image because limited screen density. So If a complex image is there, then that electron beam, as it will have the limited screen density, it cannot draw the complicated images. And it has limited color capability. So less number of colors are associated with that vector definition. So here, these are the three drawbacks of the random scan display. So these are the points of differentiation. Raster scan, picture with better contrast. Random scan cannot produce the contrast. Memory does not store intensity values of the pixels. Here, the less resolution. In random scan, it is having high resolution. Then raster scan produces curves better, and in random scan produces smooth lines, because it is the vector wise working or vector drawing kind of activity. And here the pixels are getting plotted, so you can easily plot the curve by making use of pixels. But as I'm using here the vector drawings, the lines will be easier to draw than that of curves. It is used in the systems to display the realistic image. So raster scan makes use or it can display the realistic image clearly. But here the realistic images cannot be drawn as it is working with the vectors. Here the cost is less. Obviously the cost is less because I need to have only the electron beam, and which is moving along the screen. But here the cost is more because you need to focus on the intelligent electron beam. You have to have the processor control over the drawing, and that's why the cost is more. This is used for point plotting, and it is used for line drawing because vector display is there. Example is TV sets over here, and here you are having the pen plotter. So these are the points of differentiation between the random scan and raster scan methods. All of you are getting up to this?
Yes, ma'am.
Okay. So the differences of random and raster we have seen. Now next things or different types of display devices are flat panel display. Then we will see the plasma display and the LEDs, LCDs that we will see. So in flat panel display, a class of video device, it is a class of video devices that have reduced volume and weight compared to CRT. So you must have seen the old monitors. It is a box-like structure. It is a box-like structure which is having one in my PPTs. It was there, no? This one. These are the old monitors. It is a box-like structure which has the electron beam situated at the back, and it is throwing the electron beam on the output screen. So this is how it is the structure of this CRT. So more realistic image I will show you. Okay, here. So you have seen this type of computers. Okay, so these were the monitors earlier present. It has this electron beam at the end, electron gun, and that shoots the electron beam and it will fall on the output screen. And you are able to get the output in terms of RGB color or black and white color. So this was the earlier video monitor, and it is having the large structure, but that is compressed now as we are going to see the next generation display devices. Okay, so flat panel display. So earlier, whatever the size and volume weight was there of CRT, that is reduced in this flat CRTs. So it is very important that it has reduced the volume and weight of earlier CR or old CRTs. A significant feature of flat panel displays that they are thinner than the CRTs. Obviously, the thickness has been reduced. They are thinner than the CRT. So current uses of flat panel display are small TV monitors, calculators, pocket video games, laptop computers, advertisement board in the elevators. So these are nothing but the examples where we are using the flat panel display. Now, how this flat CRT works? So earlier, in a box-like structure, we are having the electron gun, which is placed horizontally with respect to this screen. But now, or we can say that as this is your output screen and this is your electron gun, they are perpendicular to each other. Electron gun is perpendicular to the screen in earlier CRTs, but in flat CRT, these electron beams are parallel to the screen. So this is your output screen, and these are the electron guns. So they are not perpendicular to each other, but they are parallel to each other, so that the space required is getting reduced. And that's why the panel becomes thinner than that of the earlier method. So this is the flat CRT, and it has the electron beams. They are kindly make sure that your mic is off. So here the electron beams are parallel to the screen and then deflected 90 degrees to the screen. Saurabh, roll number 10. Okay. So here the electron beams and these guns are parallel to the screen, and they are deflected with 90 degrees through electric or magnetic deflectors. So they are passed, and instead of making them to fall on this edge, they are deflected by this electric or magnetic deflectors. So the electron beams are moving in this direction, and suddenly they are deflected with 90 degrees. And they are made to fall on this output screen. बरोबर आहे. अर्लियर जी गन ही 90 डिग्री परपेंडिक्युलर अवेलेबल होती, ती मी आता पॅरलल अवेलेबल केलेली आहे. आणि पॅरलल म्हटल्यानंतर ते सरळ इलेक्ट्रॉन बीम जातील आणि या एज वरती coincide hotil, or they will fall on this edge, but we make them to fall on the screen by providing this electric or magnetic deflectors. Okay, so they are using the electric or magnetic deflectors and with 90 degree deflection. And again you are having this shadow mask. So shadow mask ahe, so all beams are coinciding, they are getting concentrated at this shadow mask, and then they are following on this phosphor coated screen. Okay, so this is how the flat CRT works. So internal arrangement only we have changed. internal arrangement we have changed. Earlier the gun was present at perpendicular to the screen, but now we are mounting them parallel to the screen, and we are able to get the output through this shadow mask. Same is the case for plasma TV or plasma panel. So in plasma panel, ह्याच्यामध्ये काय असतं तर it is having a gas layer inside it, neon gas layer between the two glass plates. So you are having the two glass plates here, and in between the two glass plates, the neon gas layer is present. Now, what this neon gas layer is doing, that when you apply the high voltage on this horizontal and vertical conductors. So here I am having the horizontal conductors as well as the vertical conductors present, and gas is present in between these two. So when I apply the high voltage to these conductors, then the ions in the gas will move, or they will glow. They start glowing, and due to that the output will be getting displayed on this monitor. So here, by applying high voltage to a pair of horizontal and vertical conductors, a small section of gas at the intersection of conductors break down into glowing plasma of electrons and ions. So gas molecules which are present in between, they break down and they forms electrons and ions, and they start glowing. So that plasma start glowing, and we will get the output on the output screen. So this is how the neon gas is useful. Am I audible now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, actually the connection has lost. Okay, so we were learning this plasma panel. So in plasma panel, in between the two glass plates, the vertical and horizontal pair of conductors are present. As the high voltage is provided to these conductors, the gas which is present in between, so neon gas is present between these two conductors, those gas molecules are break down. Those gas molecules are break down in form of electron and ions, and they start glowing. And as the those ions start glowing, we will get picture displayed on the output screen. So that is how the plasma panel works. So this is again a thin output video device. Next type of display device is LED. So LED, we are all knowing that it is composed of 3 lights. So matrix of diodes is arranged to form a pixel position in the display. The picture definition is stored in the refresh buffer. So always the refresh buffer holds the picture definition, that is the information about the picture to be displayed. And the diodes are matrix of diodes are present, which will have 1 pixel at a time. So 1 pixel is made up of 3 colors here. The information is read from the refresh buffer and converted to voltage levels that are applied to the diodes to produce the light patterns in the display. So depending upon the intensity of the first, the information about the picture is stored in the memory, that is buffer, refresh buffer, and that information is converted into voltage levels. So whatever the picture is stored, that is read, and it is converted to the voltage. and depending upon the intensity of that color, the particular light patterns are getting displayed on the output screen. So this is how your LED works. Now about LCD. So in many equipments, we are using this LCD like calculators and laptops. It is liquid crystal display. So it produces a picture by passing the polarized light. So in LCD, there are number of partitions present. There are number of partitions present, and the polarized light is passed through the partitions. And then if the light is polarized, that is if the light is at right angles, then we are going to get the output. Otherwise, on and off states are observed. So we will see it in the next slides. That is how the working of LCD is carried out. So it is used in small systems like calculators and laptop computers. It produces a picture by passing the polarized light through a liquid crystal material that can be aligned to either block or transmit the light. So here we are allowing the light to get block. So either we are blocking the light or we are transmitting the light. So we are making the structure in such a way that the polarized light will either get blocked or it will get passed. So if it is blocked, then we are calling it as a off mode. And when we are able to transmit the light, then we are going to call it as a on mode. So on and off, these are the two modes. Then there are two glass plates, each containing light polarizer at right angles to other plate. So if one glass plate is having vertical bars, vertical polarized light slots, the other is having horizontal kind of slots, and that's why they are right angles to other plate. So one is vertical polarized light, one is passing the vertical polarized light, and other is passing the horizontal polarized light. So rows of horizontal transparent conductor and columns of vertical conductors are there. So rows and columns indicates horizontal and vertical sections for passing the light. So let us see the diagram of it. Okay. So here it is one mirror. This is one glass filter. This is other glass filter. And you are having a polarized film. You can observe here the vertical polarized slots, and the other is having the horizontal polarized slots. So they are at 90 degrees of each other. Then this is the displayed output screen, and here you are having the liquid crystal layer. So here liquid crystal layer is this, and you are having the positive and negative kind of electrodes to both sides of this liquid crystal layer. And depending upon that, by using these electrodes, we can change the path of the light. We can change the path, whether it is moving horizontally or vertically, that is polarization of this light will be changed. So here the mirror is passing the light. Then as it is vertical, so the horizontal light will be converted into vertical and then passed further. And it is passed through the liquid crystal layer. And once this vertical layer is converted into horizontal, only those will be passed further, and the remaining, those who are vertical in nature, they will be rejected through this horizontal polarized film. Okay, so depending upon the polarization of the light, the certain light is allowed to pass through this horizontal and vertical filter. So here you can see the off states. So off state is nothing but here it is a vertical polarization. Here it is the horizontal polarization. So a light when passed through it vertically, then these liquid crystals, if they are allowing the light to pass as it is. So this is the vertical polarization of the light, and if we are not applying the voltage, that is to turn off the pixel, we apply a voltage to intersecting conductors to align the molecules so that light is not twisted. That means we are allowing the light as it is to pass further. So this vertical polarized light will fall on this, and as it is a horizontal polarization effect on the second glass slide, the light will not pass further, and that's why it is called as off state. But in the next case, you can see here we are applying the voltage such that the vertical polarized will twist and it will be converted into horizontal polarized light form, and then it will be passed through this horizontal polarizers, and then we are able to get the output on the screen. So by twisting it, by providing the certain voltage in this LCD layer, that is liquid crystal layer, we are applying the voltage to turn or to twist this light, and this vertical will be twisted, it will become horizontal, and then I am able to get the output on the screen, and this is called as your on state. So this is how your LCD works. Okay, so now all the output devices that we have already studied, whatever the video display devices. Now only the input devices are remaining, and that we will see in the next lecture. Okay, so we will stop here. We have seen all the output devices: LCD, LED, plasma, then raster random scan display, color CRT, and only CRT. So these are the different things. These are the different display devices that we have studied, and only the input devices are remaining, that we will see in the next lecture. So till that time, give attendance. Who is absent? Only one student is absent. 15 is the strength, no?
Yes, ma'am.
Roll number 5 is there? Yes, it is there. 6 is there. 7, 8, 9, 10, 11. Roll number 12 is there?
Absent.
Yes. Okay. Roll number 12 is absent only. Okay. Right. Thank you. So we will stop for today, and we will be finishing the first chapter in the next lecture.
Okay, ma'am.
Thank you.